recording. Okay, yeah. Okay, so we have discussed, the basic model. In the last class, we have discussed the basic model of standard template library. So actually, there was a very nice talk which actually explained this concept very nicely. Okay, so so what is the concept, right? So the concept is that you have roughly, I mean, depending on how you sort of think about it, you have 2 or 3 different types of objects, right? So when you are trying to write any program, right? So one is what is called this containers. So containers are basically, you can think of them as data structures which store data, right? So those are containers you have seen, okay? Then there are these algorithms. Okay, so algorithms are basically things that you work with, right? And the algorithms, depends on the container. Okay, not all algorithms are possible in all containers. So maybe if there is a map container, okay, maybe the sort algorithm does not make so much sense. Okay, so we'll come to this. Okay, but by and large, many combinations are possible. Okay, so this is one thing. Okay, additionally, if you think about it, there is a third type of thing, which is the type of the object which is there in the container. Okay, so for example, you can have vector of integers, you can have vector of strings, you can have vector of complex numbers, you can, any user defined type can have vectors. Okay, so there are all these things, right? So all these combinations. So the main problem that the designers of the STL or standard template library they were facing, he's a person by name I think Stepanov, okay, and he used to work in, I think, HP Labs or something. Okay, so what he basically came up with this idea of iterators. Okay, so what is the, why was this concept of iterators needed? This concept of iterator was needed simply because you can have, so for example, your, let's say, find algorithm. Okay, so find algorithm can find objects in a vector, objects in a list, objects in a map, objects in an unordered map, and so on and so forth, using the same concept, which is the iterator. Okay, so there is a uniform interface for the find algorithm to access these containers, okay, and work with it. Okay, so that is the key idea of, so that if one thing that you want to take away from this standard template library, it is this concept that instead of taking all combinations, so if there are let's say n1 different types of containers and n2 different types of algorithms, then instead of having n1 cross n2, okay, and again this can also be like crossed because there may be different types, different object types. Okay, but let's say template handles that. So even with that, in order to not have n1 cross n2 different prototypes of, let's say, these algorithms, okay, you need this concept of iterators. Okay, so this is the basically the key takeaway idea. Okay, so so we have discussed this, and we have discussed what is the overall concept of iterators. Basically, you have you sort of impose an ordering. The iterator imposes an ordering. Okay, and basically there are two main functions: begin and end. Begin points to the first item, and end points to the, like, a virtual item after the last item of the container. So this is true for any container. Okay. even though the container may not be stored in a list format, like for example this set or map or even unordered map. Okay, so yeah, so these are not stored in a linear format by definition, but when you operate using iterators, there is a certain linear ordering which is given. Okay. Um, okay. So now what we say is that yeah. So this find algorithm you have seen. So let us see some of the algorithm. So I hope this find algorithm you understand. Okay. Um, yeah. So yeah. So these things all we have covered. Okay. Now let us look at this another important concept, okay, which is that your algorithms, okay, can also so up till now, you have seen the algorithms which so what is, for example, if you just recall the find algorithm, what does it do? It takes in this begin and end, okay. So it takes in a sequence, okay. So you can actually you can give the begin and end, or you can give any two other iterators. So it basically takes in an iterator range, okay, for an object, okay, and it just compares something and finds, okay. But you actually want to do much more. So let us look at this find if example, okay. So for example, you may want to find, okay, if there is a let us see here, okay. So you have okay, so let us see this example, okay. So this example will make things clear, okay. So let's say you are given a vector or something, some container of integers, okay, and you want to find if there is a odd integer in there or not. And if you find let's say if there are many odd integers, so it should return the first odd integer in that particular iterator range that it want to find, okay. So how do you go about doing it, okay? So the way to go about doing it is that you basically use this predicate version of the find if algorithm, okay. So find if algorithm, it takes, you see here, it takes this iterator type int, and it also takes another type which is a predicate, okay. So we'll come to what this predicate is, but essentially so it is taking the first and the last range, okay, and it is iterating between them, okay, and it is checking whether this predicate is true for the current item or not. If it is true, okay, then it returns the current item, okay. Otherwise, it returns the end of, basically it will go to the end and then it will return, okay. So this is the idea about the find if, okay. Now what is this predicate? So you see, it is predicate is being called here like a function, okay. So what can you pass, okay? Okay, so first thing you can pass is you can take a function like this, so Boolean function odd, which takes an integer int, okay, and it returns basically I modulo 2, okay. So it returns true if the yeah, so basically this I modulo 2 is false if it is even, otherwise it returns true, right? So that is the idea, okay. Now here okay, let me see the function call, okay. Yeah, so actually this is a different, so what you can do, you can call it like this simply, okay. So you can say vector angle bracket int colon colon iterator. So this is the iterator type in the vector. We'll see this part how this comes, okay. But then you get this iterator, you are defining this iterator. So find if basically will return the iterator and copy it to P, okay. You are given this iterator range v begin and v end, and you can simply say ODD here. Okay, so you can simply pass the function pointer, okay, which is, as you know, given by small ODD. Okay, so yeah, so this is one thing that you can do. Okay, but what is more in line with this C++ is that you can pass what is called this function object. Okay, so what is this function object? So function object is basically a type, okay, where this this function dereference operator has been overloaded. Okay, and basically you see that this operator, the function operator, has been overloaded to return a boolean. Okay, and basically it yeah, so it takes an integer int I as input, okay, and it returns whether it's odd or not. Okay, and now what you can do, you can simply just call this odd to make a new odd object. Okay, and you can pass this odd object to this. Okay, and this odd object is what is called a function object, or also sometimes called a functor. Okay, FUNCTOR. Okay, so you can also pass a functor object here. Okay, there are also other ways. We will not see them here so much. I will just briefly mention, but these are the two sort of ways that you can understand that I mean, you can understand with your current knowledge. Okay, so so now yeah, so function object. Okay, now what is the advantage? Why would you want to have this kind of function object when you can have this this kind of a boolean? Okay, so here is the thing, right? So now because you have this function object, okay, so for example, you can have a functor called less than, which is a parameterized functor. Okay, so you can simply define it like this. So you can say template class T struct less than. So you can read struct as class. Okay, so there is not much difference between struct and class. Okay, in C++. Okay. Yeah. So and then T val. Okay. So it stores a value. And then, of course, it has a constructor which initializes the value. Okay, so this is the second line. Okay, and of course, it has the overloading of this this Boolean operator, which takes in this takes in an input of type T, and then it has less than, and so on and so forth. So less than operator is already defined for integer. Otherwise, if you are using it with some type, you have to, that type T has to have this less than operator defined. Okay. Now, if this is the case, okay, then what you can do is you can basically call something like this. So find the first element which is less than 43 like this. So see how simple it becomes. Okay. So you are saying, in this range v dot begin to v dot end. So you have a vector v. So in the range v dot begin to v dot end, you just want to find something less than 43, and you can pass anything here. Okay. So for example, you can say some list of string is there. Let's say ls. So you can say ls dot begin and ls dot end, and then less than perfection. Okay. So there is the, for strings, there is the less than operator defined, which is something like the alphanumeric ordering. Okay, and so it can work like that also. Clear? So now, so basically what you are doing, so what are the things that you are gaining by using function objects as opposed to raw function pointers? Okay, so the first thing is that it's quite somewhat non-intuitive, but this this function objects is actually very efficient. And the reason is that you see, if you pass function point, is there a question? Okay. I hope you can hear me, right?
Yes.
Are you able to hear me? Okay, yeah. So the reason, these function objects are more efficient is because you see, if you have to pass a function pointer, okay, you cannot use an inline function, right? So because the function pointer is an address of the function, and you can have that function pointer only if the function is not an inline function, okay? And if it is not an inline function, then every time you call that function, you have to create a stack frame, even though that function is like a small function, something like this, you know, this let us say this odd function, right? So it is just saying return I modulo 2. Okay, this can easily be inline, but if it is inline, you cannot pass the function pointer. Okay, so this is one thing. Okay, but here on the contrary, you see this Boolean operator is almost always inline because this is a very simple function. There is no recursion, nothing. Okay, so and it is defined inside the class. So by default, okay, the compiler will try to inline this operator function. Okay. So this is inline, and what that means is that there is no overhead of stack frame creation. Okay, so this is somewhat one may think that in terms of code, actually this function object is very bloated and this and that, but actually it turns out that this method is much more efficient. Okay, so this is one part. The second part is that you can obviously store, it's an object, so you can obviously store the state of that particular functor. So the functor can store many different other informations. Okay, so and that allows you to do much more, many more different things, which are obviously can be done using functions, but then you have to have some sort of either global variables or some sort of static variables, and it becomes very messy code, right? So this is the so basically you should use function objects wherever possible. Okay, I mean, not wherever possible, almost always you should use some sort of a function object. Okay. 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 Yeah. So so these are also see, I don't know if you guys know about functional programming. Okay. So so C++ is a core object-oriented programming, and these two paradigms are somewhat different. So yeah. So in this particular course, we will not be talking about functional programming, but many a time. So in recent times, a lot of languages actually try to support some functional programming features in C++. Okay, and what is functional programming? Key idea of functional programming is that you should have functions as first-class objects. Okay, and then you should be able to have higher level functions, basically. So you should be able to pass functions to other functions and so on and so forth. Okay, so this is kind of emulating little bit functional programming in C++. Okay, so yeah, so almost also, for example, for Java, so Java also now supports some functional programming paradigms. Okay. There is a language called Scala, which also supports functional programming over Java. Okay. Then there is Python has some functional programming paradigms and so on and so forth. Okay. Okay. So now Um, yeah. So another thing is that, with this function objects, okay, you can do this policy parameterization. So what does this mean by this policy parameterization? So basically, suppose your input type, okay, in the container is of type record, okay, it has string name and char address, okay. Now what you can do, you can define these functors, okay. One is CMP by name, and if you see here, the name is a string, okay. So you simply return a dot name is less than or equal to b dot name. So here basically yeah. So here your operator is taking in two arguments. Okay. So yeah. So CMP by name is basically taking in two arguments, the first one and the second one. Okay. And similarly, CMP by address is also taking in, two arguments, A and B. And basically, yeah, so these are of type record. But now it is comparing this A.addr to B.addr. And if you see here, these are just strings, okay, C style strings. So you have to use something like C comparison, okay. Now all this code is hidden inside this CMP by name and CMP by EDDR, okay, ADDR, okay. So you can have this very simple call where you say, so sort is another algorithm which is implemented, let's say, okay, which takes again a iterator range. So you have like vector of records VR, okay, and you have this iterator range VR begin to VR end, okay, and you can call it by CMP by name, or you can call it by CMP by ADDR, okay. So the user code becomes very simple and very nice. So this is the other advantage of using uh, function objects, okay. You can basically create objects to, basically, so this is sometimes called policy objects, okay. So you are sort of creating these different policy objects to implement different policies, okay, for the same function. Okay, yeah. Yeah, so this is just if you do it. So actually this code you need not understand, but just for mentioning. So this is what is called a lambda, okay. So you can also create an in situ function, okay. Okay. This is only available from, I think, C++ 11 onwards. So your C++ 98 will not have this, okay. But yeah, so you can see that if you try to put it in the code there itself, it becomes a little bit noisy, and it's not so intuitive a code, okay, compared to the code here, for example. Sorry, here, okay. It's very easy to understand, okay. Okay. Yeah. So yeah. So basically, this is a summary of what we just discussed. That basically based on, you can choose based on efficiency, clarity of code, etc. Okay. And in all cases, basically, best is to use function objects. Okay. So function objects are the best. Okay. Okay. Now, yeah, so now let us just get into some of the containers. So I'll not get into detail of all the containers. So let us look at, so probably vector is the most commonly used container. So we are just showing some of the fields. So it's a templated class, as you can see, with the type of the elements as container. And it is implemented as an array. Okay, so vector is implemented as an array. Okay, and all these containers will have this value type, iterator, and const iterator. Okay, so this is true for all containers. Okay, now value type, of course, in this case will be set to t. Okay, iterator is dependent on the implementation. So as you can see, the so now you can understand, right? So as a programmer, you access it as a vector within angle bracket, whatever the type is, okay, and then colon colon iterator, right? So if you look at this particular code, for example, where should I see that code? Yeah. So this particular code, right? So vector int colon colon iterator. Okay. This is the type of the iterator for a container. So if the container is map, let's say map of int comma string or string comma int, something like that. So it will be map within angle brackets, string comma int. Okay. Then colon colon iterator. Okay. So this iterator type is what is defined here. Okay. So this iterator type is defined using keyword here, which is actually the type which that particular implementation uses. So for example, for vectors, iterator could be of type T star. Okay. So it is just a pointer to type T. Okay. But for a list, it could be struct node star, something like this. Okay. So whatever it is, okay, you can get it using this iterator type. And similarly, you will have a const iterator type. So these are the two things. Okay. And then you will have these functions. This we have already declared, discussed. You will have iterator begin, const iterator begin, iterator end, and const iterator end. Okay. So, these are the things. Okay. These are some of the fields. I mean, a little bit, into how the vector class is actually defined. Okay. Yeah. So I think other things you understand with vectors. There is one thing with vectors. So there is this insert or erase function which is provided. Okay. Okay. So if you do something like an insert, okay. Okay, so in this case, you can see that you can go to P, okay, and your Q is pointing here. So your P was begin, and then you have done plus plus P 3 times. So your P has come from here to 1, 2, 3. So it has come here now, okay. And your Q is here. Now, when you do insert, okay, it actually inserts the 99 element here, okay, and all other elements are shifted, okay. So now this other iterator Q is invalidated because it is still pointing here, okay. So for the vector class, okay, if you use, so insert is provided, but if you use insert, okay, or erase, okay, the other iterators are invalidated. So so actually and so there is this is one thing. The other thing is that you see the entire array is being moved. Okay. So it is better not to. So if you are going to be using insert many times, okay, during your code, you should not use vector. Okay, you should use list, because that is there the insert and the erase operations are much more efficient. Okay. Yeah, and in those cases, the iterators remain valid. Okay, so but while insert function is provided, it is not recommended that you use insert and erase operations too much with vectors. Okay. Okay, so this is, I think, done.
Sir?
Okay. Yes.
Sir, after insert, does the like the addresses are changed completely? Like the entire thing is copied into another like array?
No. So what it says simply is, so most likely the whole thing is moved. Okay. Now this is not specified. So see, the implementation may differ. Okay. But as a general rule, what happens is everything is not changed. It is simply moved one. It's a somewhat complex. So most implementations, what they do is, so one other thing is that with vector you can grow the array. Okay, so the way they grow the array is there will be some allocation, and then if there is insertion in the back, there will be another allocation in another place which is contiguous. Okay, so it's all very complicated. The key thing to remember is that if you do insert or erase into the vector, then all your iterators are invalidated for that vector. Okay, so you should again get the iterators for that vector. Clear? So at the time of writing your programs, you should basically work like that. Okay.
Okay, sir.
Is it clear? Yeah, yeah. So it depends on the case and the situation, that whether, so in this case you are seeing that because we have inserted 99 here, Q is now pointing to 3. It may not be always the case. So for example, if it is between boundaries of two different allocation or something, the whole thing may slightly change. Okay, so nothing guaranteed there. Okay. Okay, so that brings us to the list. So list again, you know, it is like a doubly linked list. Okay. Again, all these things are there. It has a value type, it has an iterator, it has a const iterator. Okay. And you can have insert and erase. Okay, as it is. Okay, and everything works basically. Okay. Yeah, so basically in this case, the plus plus takes it to the next element and minus minus takes it to the previous element, and insert is fine. So no, so nothing changes. Okay, so this is the other thing. Okay. Yeah. So ways of traversing a vector, like said, so you can traverse it like this. You can traverse it using an integer. You can traverse it using the size type. So size type is slightly more correct because there may be some systems where the index is and the integer are not of the same type. So then the conversion may leave something, some errors. Okay. So the correct way to do it is to use this size type. Okay. This you can do. Okay. And you can of course do the iterator.
Sir, please repeat the previous one.
Sorry.
Please repeat the previous one.
This one, this size type.
Yes, sir.
Okay, so see, so you can, if you use this, let's say you have a vector v, you can use vi like an array. Okay, so vector allows you, so it has overloaded this array indexing operator to use integer as the index. Okay, but the standard says, so mostly this index is actually integer. Okay, for most implementations. Okay, but actually the standard says that this index is of this size type. Okay, the way this is, the reason this is put like this is because on some architecture it may so happen that your integer is very, very small. Okay, but you want larger indexing. Okay, so you want to index. So if it is like if your integer is just 2 byte, you can only index up to 32,000, or I mean, if it is an unsigned thing, then you can index up to some 64,000 something or 65,000 something elements, right? So so you may want to have a larger array. Okay, and in that case, you may want to have a larger size type. Okay, so that is the reason why this is done. Clear?
Yes, sir. Sir, but we could also use long int if that's a problem.
Yes, but the question is, you write, whenever you are doing software engineering, you have to be, so once you write the program and ship it, you have no control over it. Okay. So,
oh, okay, got it.
Yeah. So, okay. See, this is the mindset change that you have to come to. Okay, you up till now, when you are learning to program, okay, you are writing the program and the only user of your program is yourself, okay? But that is not the case in real world, right? Your program will be developed collaboratively and will be used by so you should, your frame of mind should be like that you know, I should work like that. Okay. 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 So yeah, so and then this iterator is there. So iterator is of course a uniform interface. Okay. 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 Yeah, vector versus list. Again, there are some suggestions here. Essentially, the idea is so mostly you can use vector, except that in situations where you need to do insert and erase inside the vector, okay, a lot. In that case, and yeah, so in that case, basically you should use a list, okay? Otherwise, you should just use a vector simply because it's more efficient, okay? Yeah, we'll come to map and unordered map in a minute. Okay, yeah, so this is okay. Yeah, so now you see, so we have talked about containers, we have talked about iterators. Okay, now let us talk a little bit about some of the other algorithms. Okay, so what are the different types of algorithms you can use? So you have already seen find and find if. Okay, you have already seen sort algorithm, okay, which takes in a comparator and sorts, okay. You can, yeah, so another class of algorithms is this accumulate algorithm, which basically, so one thing you should note here is that whenever we use sequence basically means an iterator range, okay. So there is a first and there is a last. So if you know, it could be begin and end, in which case it covers the entire container, okay, for any container, but it could be also something in between, okay. So you could have gotten two different iterators from two different algorithms. Maybe, you know, initially you found, let's say, the first odd number and the you know, the last even number or something like this, okay. And then you want to you know, search in between this only, okay. So then you can use that iterator range instead of the begin and end, okay. Now for all sequences, so sequence is basically an iterator range. So for all sequences, okay, you can do an accumulate, okay. So you can, for example, what accumulate does is it basically sums up the entries of the sequence, okay. And it takes an initial value. So for example, if you just want to compute sum, you can sum of a vector. You can simply say accumulate v dot begin, v dot end, and 0. It will provide you the sum, okay, of a vector of ends, okay. Now, yeah. So yeah. So, but of course, you can do all of this. Okay. These are some of the other ways you can use. So you can use it for double. You can use it for long, and so on and so forth. Okay. Yeah. Yeah. So now what you can do, so this is where it gets very, very close to functional programming, right? So in sort you have already seen, but now you see here, what it is doing is, you can also do a functor based sum, okay? So you don't have to do you don't have to only use the plus operator, okay? So one thing you could do is you could overload for the type T the plus operator itself, okay? But suppose for some reason you don't want to do, and you want to do some kind of a special aggregation, okay? So what this will do, sorry, this should be init plus is equal to, okay? So init value is there, okay? and then it will be yeah. So yeah. No, sorry, it's not like init plus is equal to. So this is correct. Yeah. So this operation, this op, so init will be assigned this op of init comma star of first. Okay. So first is the sort of the running iterator. Okay. And what you are doing here is you're basically doing the operation between init and first, and then you are assigning it to init. Okay. This is what accumulate is doing here. Okay. Okay. So for example, you could calculate the product of the vector by using this long double beginning long double end. Your start value is 1. Okay. And you use this multiplies functor on doubles. Okay. Which is already there. Okay. Which instead of doing sum, it actually does a product. Okay. Okay. So this is again the other thing, and this is basically your this is basically going into sort of functional programming. So in many functional programming languages, you will see that this operator will be called something like reduce operator. Okay. Yeah. So that is the accumulate operator here. Okay. 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 Yeah, and yeah, so this is I think another way of doing simply accumulate. Okay. Okay, let's skip this one. Okay. Let us go to another example. So another example as in another algorithm. Okay, and the algorithm is inner product. Okay. So now up till now, whatever you have seen, okay, it takes only one iterator range, okay, or one sequence, okay. What inner product does is it actually takes two iterator ranges and then does so. It is something like the dot product that it is taking this iterator range or this sequence from one vector, and this is taking another iterator range from possibly another vector, or could be from the same vector also, doesn't matter. Okay. Uh, and then it is going to, these should be of the same size. Okay. And it is going to basically multiply the corresponding elements and sum them up. Okay. So this is the applicability. So it takes iterator type in. Okay. So this is the first type of iterator, first and last. Okay. And it also takes into. So this could be another completely different type of iterator. Okay. So this could be from a vector, let's say, and this could be from a list. Okay. And it will do a dot product for the two. Okay. So this is the algorithm. So hope this is clear. So this is another type of algorithm that you can have. Okay. Okay. Yeah. So this is an example of how you can basically multiply the price and the weight, this Dow Jones weight. Okay, to actually calculate the total weighted sum of the stock prices. Okay. This is how you basically sort of compute the industrial index. Okay, so yeah, I mean, for those of you who know, like there are these funds which basically have certain weightage of their investment into different stock prices, right? So the value, the index value goes up and down depending on the weightage, okay, of the different stock prices, okay. And that's a inner product operation. Okay, so I think this is clear. So let me just ask any questions up till now. I mean, I've been going a bit fast, but that's because I'm hoping that all of you are now, kind of experts in programming. So any questions or comments up till now? I mean, I think we are so we have mostly covered most of the important stuff. Maybe we will cover the map a little bit. Any questions or comments till now? Okay, very good. So, okay, so yeah, so this is the inner product. Okay, now there are two things. One is called the map, another one is called the unordered map, and these are very, very useful. I mean, in C++ programs, they are not used so much, but these form the basis of, so for example, those of you who know Python or something, you know that Python is written in C++, okay? And one of the main things about Python is its hashes, you know, and those are basically unordered unordered C++ maps. Okay, so from that point of view, it is very, very important. So what is a map? First, let's see what is a map. Okay. So map is basically both map and unordered map. They store this key value pair. So it is like so you define the map something like this. There's a key type and a value type. Okay. And so a classic example is this. Suppose you want to in a text, in a given piece of text, you want to store frequencies of occurrence of all the words. Okay, so this is you know, a basic data mining or data processing task. So in that case, what you do is you create a map of type string comma int. Okay, and you call it words. Okay. And then what you can do is you can basically say that you are, you know, for string s, in s, okay? So basically you're taking a string as an input from standard input. So basically the document is coming the standard input, okay, until it ends, okay? And then what you are doing is you are incrementing the count of these words of s, okay? So this map basically, again, it has overloaded the indexing operator to take in the key type, okay, and it returns basically the value type. Okay, so yeah, so is is subscripted by a string and it returns a int in this particular case. Okay. Yeah, and in fact, what you can do, so once you have defined these words, you can, so again, this auto you don't know. So so basically, I think again, C++ 11 or 17, or I don't remember exactly. So you can let the C++ compiler, you know, determine the type of an object. So so this colon keyword actually gives you an iterator over this container. Okay. Sorry, it gives you an iterator range over this container. Okay. And basically, so here you can simply simply iterate over that iterator range using this auto thing, where basically this P is the kind of the iterator. Okay, so P gives you the running iterator for that particular iterator range. Okay. And now, yeah, so you are just outputting P dot first and P dot second. Okay. Yeah. So that is yeah. So this is again using some sort of pair thing. You need not worry about that currently. Okay. So yeah. So what it is basically going to print is it's going to print something like this. Okay. So so this is a simple word count program that you can do using a map. So this is one utility of a map. Okay. Yeah. So the thing is that in C++, the way this map is stored is using something like a binary tree, okay, an ordered balanced binary tree. Okay, so this is how a map is stored. Okay, so you can see that there is an ordering here. So the iterator is kind of fixed. So if you iterate over a map, okay, so apple is less than grape, and then kiwi, and then orange, and then plum, and then quince. Okay, so this is the ordering, like the binary tree ordering. Okay, now so basically there are two things, right? So one is that so when you are so the ordering is fixed, and you can find like you can yeah, so your iterator basically follows this ordering. Okay, and because it's a balanced binary tree, so you basically, if you have n elements in a map, your find or something is order log n. Okay, so these are some of the things that you can do. Okay, now if you have if you have an iterator, okay, then you have order 1 access to the element. But if you are accessing using the index, so for example, if you try to access it like fruits within bracket grape, again that is going to do a traversal. So worst case, order log n access is provided to basically the value for a given key. So if you input the key and you want to get the value, okay, then it's worst case order log n. Okay. Yeah, again, I think this thing is clear. I don't see anything here. And again, you can basically you can do insert, erase, everything in case of a map. Okay. Okay. Yeah, some example. Let us skip the example. Yeah. So now in C++11, you have this unordered map, okay, which is a hash table. So the difference between hash table and this map, so that also stores a key value pair, okay, but there the access is like constant time. So the access to the element given a key value is constant time. At least it's amortized constant time. Okay, depends on how the hash table is implemented, but yeah, worst case it may be slightly more, but so that is the advantage of this unordered map. The disadvantage is that you don't have any kind of so you can use iterators, but iterators don't follow any particular ordering. Okay, so that is the so for example, they are not sorted on the keys. So that's why the map and the unordered map. Okay, unordered map, iterator on the unordered map will not be sorted by the key, but an iterator on a map will be sorted by the key. Okay, so this is the other difference. Okay. Accordingly, you can use one of them. Okay. Yeah, so here are some of the other algorithms, like you have already seen found. You can do a count. Okay. You can do a copy. Again, copy algorithms are there. Okay. And you can find ranges. So there are algorithms. Okay. Which can actually find ranges based on. So for example, here R is a subsequence of this particular BE range. So B and E are iterators. Okay. With the value V. Okay. So you can also so instead of finding the first element, you can also find range for all the equal elements, and so on and so forth. Okay. So there are many such functions. I think roughly there are about 60 such algorithms which are implemented in STL. Okay. Yeah, copy. Yeah, so sets are again not very used, simply because sets are like maps except without the value. Okay. So that is the only difference between maps and sets. Yeah. Okay. So yeah. So this we have discussed. So most of the algorithms either take a unary function object or a binary function object, and you know which one takes which one basically. I mean, you can just check. Okay. Yeah. Yeah. So that kind of ends our exposition to STL. Any question or comment? I'm actually open to all. So you know, in general, what did you guys think about the C++ section? Do you have anything to comment? So first of all, on STL, do you have anything to question or comment? Anybody?
Sir,
Like,
what did you mean exactly?
Sorry.
I did not get your question exactly.
No, as you understand, so today is the last class for the C++ language. Okay, so after this, Professor PPD will teach the software engineering principles. Okay, software engineering, various things about software engineering. So, any questions or comments about the first half of the course? So, anything that you did not understand, you know, anything that you think should be added or removed? I mean, any particular issue. Yeah.
sir, I had a doubt in STL.
Mhm.
Like, is it recommended to use unordered maps while implementing any software? Because hash tables depend largely on like what is the exact data which is being used to store key value pairs. So that's my doubt.
You mean the type of the key and the type of the value, or?
Like the hash function might perform very poorly on certain data sets, right?
Ah, yes, 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 yes. Um, yes, so certain types of keys, the hash function might perform poorly. Yeah, so if you fear that, then you should probably use. So just for you know what I think sorry, I didn't catch. So I think whatever. So what your friend is trying to say, yeah, for the benefit of others, is that you know, depending on how the hash function is distributing the keys into different buckets, there may be a lot of clustering, and then your access time may be poorer than using map. Okay, so in the very worst case, it could lead to a lot of clustering, and then you know, your access time becomes linear, so order n. Okay, and the answer is yes. But there are most modern, hashing algorithms. So there are, I mean, I don't know if you know about this double hashing and cuckoo hashing and all these things. So actually, I don't know. So it depends on the particular implementation. Okay. So I don't know which one is exactly, which hash table is used exactly in C++ STL. Okay. But actually, these things are, so hash tables, there are fairly robust version of hash table implementations now. Okay. So that is just one thing. But yes, so if there is a lot of clustering, then it may be that in certain situations, the access to the elements is faster using maps than using unordered maps.
Yes. Okay. Thanks.
But in general, it is not. So in general, it is recommended that if you are accessing your elements by the key, you should use unordered maps. That is the utility of unordered maps anyway.
Yes, sir.
Okay. Any other questions or comments regarding C++? So, you know, if you are very, very performance focused, you can also think about this Boost library, which is apparently is faster than many sometimes STL implementations. Yeah. But it is not part of standard C++. It's a third-party library. Okay. Okay, so thank you everyone.